This is Marko speaking from Renusol. Welcome to the webinar. We want to give you an overview about our new flat roof system, the FS Pro system. And we also want to give you an overview about the design and the PV configurator tool, as well as an overview about our general portfolio. Yeah, good. We have designed a brand new flat roof system. It's called the Renusol FS Pro, and it's our latest and newest system for installing solar modules on flat roofs. We are quite proud about this system because it gives quite versatile functionality. It gives you the ability to mount systems on every kind of flat roof and for different module alignment and for different combinations. I will give you an overview on that. So what's the new functionality of that system? Its main point is it is pre-mounted. Therefore, you are saving a lot of work and effort on site because, as you see here, it comes pre-mounted. You only have to put this part into vertical position, and then you can mount your module on that. You have to align the rails in the row, and you can attach them simply by using a bolt. This bolt is quite special because it doesn't require a nut, so you have only one point. And therefore, yeah, we are true to our simple, solid service motto. So it's very simple to use that system. You don't have many parts. It's very fast and very easy to use. Why is it solid? We have thoroughly tested that system. We have made extensive static calculation for the system. So every part is calculated and according to codes and standards. And yeah, we provide a world-class service because we have an on-site technical team in the UK. 2 colleagues which are available all the times in the UK for your technical questions, for on-site help. And we have also 5 trained engineers in Germany which can answer questions at any time regarding your project and also, of course, our product. So in order to sum up, the ridge and the eave supports are already attached to the base rail. You can see it here. The building protection mat is pre-glued, so you don't have to attach it separately. This saves time on site. The only thing you have to do is to set up the ridge support. It locks automatically. You have to connect the rail sections with locking bolts. You have to put up the ballast, you have to position the modules, and then you're done. So it's quite quick, and therefore we say you can save 30% of time compared to systems which are not pre-mounted. So you have at least 30% of time and of effort saving on site. The key advantages for you with that system are it is a universal solution. So you have many applications, which I will show in the following slides. You have a high quality. We are giving 20-year of warranty on that system. The condition for that is that the system is designed with the PV configurator in order to make it safe. So we fully trust in our systems, and we can give 20 years warranty because we are on the market for 25 years now, so we have extensive experience. But we want it to be designed properly with a calculation software so that the ballast is on its place where it belongs in the PV array, so that the safety is given against wind uplift and or weather conditions. I already mentioned the high degree of pre-assembly, which gives you at least 30% time advance on site. Okay, now I want to shine a light on the different options that you have with the system, and which ways can you use the Renusol FS Pro portfolio. So you have the possibility to mount the system with 10 degrees module inclinment in east-west configuration. We have different rail length available here, so that this gap which you see on the top can be made according to your needs. You have the option to leave very little space if you need a high module density on the roof, but we have also the option to put higher gaps there if you want to have gaps there so that somebody can go through for inspection or for any other reason. So there are 3 different rail lengths which we have here, so that you can design according to your needs. Why is the east-west system especially beneficial to use? It's especially beneficial because you have very low ballasting needs. In an east-west configuration, one module acts as the wind deflector for the other module, and therefore you get very low ballasting loads. And also for shifting, for south-facing systems, the ballast for shifting the system is in most cases relevant, and this is not the case with east-west systems, and therefore very low ballasting requirements. That's one reason. The other reason why east-west systems are very popular and increasingly popular are because of the high density of modules that you can put on the roof, the high amount of modules. Of course, the efficiency is a little bit less than with a south-facing system, but compared to a south-facing system, you don't get the high peak at the mid of the day. You get a more even distribution of energy production. So in the morning, you get energy production a little bit more, and in the evening, and the peak at the mid of the day is lessened. And this is especially beneficial for consumers who want to use a high amount of energy by themselves. So self-consumption is a very beneficial point with east-west facing systems. So that would be a reason to use an east-west system compared to a south-facing system. Here you see the south-facing variant in a 10-degree configuration. You see at the back of the module the wind deflector, and you also see the ballasting set. So the ballast is hidden below the module, and it's practically invisible. But the systematic is actually the same as with the east-west system. So the rails are actually exactly the same, only the rail length is different, and the other system components are also the same. So 10 degrees south-facing is available as well. We have it in 18 degrees as well. Sometimes customers from Northern Europe ask for 18 degrees because they want a higher inclination, but the most popular variant is the 10 degrees south-facing variant. We have a option which is called HL. Why is it called HL? So the abbreviation is for high snow load, for high load. There we have a third rail in the middle of the module, so that high snow loads and high wind loads can be managed. As you all know, the modules in the last years have grown constantly, so the dimensions are bigger and bigger and bigger. But the load capacity of the modules has not increased in the same pace. So everybody has to take care also of the load capacity of the module. If you're mounting a module in an area with high wind loads, with high snow loads, everybody has to be cautious, and it might be beneficial to use a third rail in order to to lower the stress on the module, in order to prevent micro cracks and all associated damages which can occur. Completely new with our new FS Pro range, we can now also offer a portrait mounting of modules. It can be beneficial if the roof requires it. So if the roof dimensions are so that you can put with the portrait variant a row or 2 row of modules more on the roof, then it could be useful to use the portrait variant. So it's possible, actually. We have it, and it can be planned, and it may give you another useful option. Of course, it's possible to mount the system on trapezoidal sheets. There we use set screws, sheet metal screws, which attach the rail then to the trapezoidal sheet. It's possible to do that. We are working for an introduction into our PV configurator software of that variant. So all the other variants that I mentioned are, as of today, in our design software. We still have to introduce that variant into our software. But in the meantime, you can send projects to our technical team, and they can do a design for you. So that's no problem. Please note that this option is available for 10 degrees south facing and 10 degrees east-west. So we are giving the option for these 2 variants. We have also worked on a combination with integrated fixing points to make it possible with our flat roof system. So if you need attachments to the roof, like nickels and fixing, etc., you can use it with our system. We have designed a new attachment, so an interface which connects then the integrated fixing point to our rails and fixations. Yeah, it's completely new, and it makes the whole process, and also the number of needed integrated fixing points is now less than it has been in the past. So that's quite an improvement. With this option, we have not yet implemented it fully into our design software. So it's been tested at the moment, but the same as with the trapezoidal sheet. If you have a project that you want to do with that option, you can give it to our technical team, and we can then do a design for you. That's no problem. Anyway, why is it beneficial to use a flat roof system with integrated fixing points? There can be several reasons. One of them could be the tilt of your roof. You know that most flat roof mounting system producers limit the tilt of the roof to 3 degrees. Renusol is different. We allow 5 degrees roof tilt for our flat roof system without additional attachments. So if a roof has an inclination of 5 degrees, everything is fine for us. So we allow 2 degrees, actually more than our competitors, which may be useful for you. But what if your roof has 7 degrees or 6 or 8 or 9? Then you can't do a flat roof system with ballasting only. And then an additional fixation to the roof would be good. And in that case, these integrated fixing points can be really beneficial. In other cases where you have very high wind loads or very high building, then you can use these integrated fixing points as well. Yeah, building height is also an important factor, of course, for the wind load and for the required ballast. Please note that we have made our wind tunnel tests according to the newest codes and standards. And it has also been third-party checked. So the tests have been done in Germany at the IFI Institute, and they are also renowned to use in the US. It has been third-party checked in the US. So it's the latest state-of-the-art wind tunnel test. And our wind tunnel tests can be used up to 100 meters building height. So we don't have a height cutoff. So, and this is different because some of our competitors can only do ballast designs up to 20 meters or something. So we can go higher. We have these, we have introduced side panels. So why have we done that? It's not due to aerodynamic reasons in order to lower the ballast or something. Actually, it doesn't have an effect on ballast. We checked that, but it's in order to make it more aesthetic. It has a nicer appearance. And also, yeah, it's actually for pest control. If you have birds or can live below the modules or something and make mess there. So that would be then an option to use these side panels in order to prevent that. So bird control is the aim here. A very nice option which comes with the system is the equipotential bonding. So you get the flat roof system with these bonding clips, which are to be put between the rails, and they connect the whole system to a grid. So it's we have the equipotential bonding there, and we have even lightning carrying capacity, and we have checked that. And we have here done a test at TUV on the FS Pro, and we have a certificate that equipotential building and lightning capacity, lightning current capacity of the system is given. And this is quite beneficial for you because you don't need additional measures in order to do the bonding of the system. And if you need lightning carrying capacity in case there is a lightning protection on the roof, you have to connect it to the lightning protection. Then you have a benefit there as well. Please note that the modules, if you want to have this equipotential bonding, you have to add to your bill of material P-clips. These are clips which are put between the module and the clamps. This is the only thing, but they are quite cheap and easy to mount. So, and then you have a system which is completely bonded and foolproof. In the last years, there was also a trend that the module dimensions have changed quite dramatically and drastically. The modules got bigger and bigger. We don't know what the Chinese manufacturers will do in the near future. Will they stay with the module dimensions as of today, or will it change again? Therefore, we have to decide it to make the system completely flexible for module dimensions. So we have put here different slots in the module rails so that this can be changed in the future if needed. Also, you are flexible if you have older modules with the old dimensions on stock, or you have a project which has to be retrofitted, etc. Then you can use perfectly our system, but because it's widely flexible module different module width and length can be catered. And please note that for standard modules, so width of 1100 millimeter up to 1150 millimeters, for these standard modules, the system comes pre-mounted. So the bolt is already set in the right position. You don't have to change anything. If you have lower or bigger module width, then you would have to change it on site. But for standard modules, it's pre-mounted and very easy to use. I already mentioned wind tunnel engineering that we did on the system. So the system is designed for optimum resistance against wind, for minimum ballast needs. It's the tests are done according to state of the art at the IFI Institute in Germany, and it ensures that you will not have problems with your projects in the design lifetime of the system. We don't reduce the safety factors for the design. It's done according to Eurocode, full safety factors on the wind load. And this is different to other manufacturers, which then limit the design lifetime of their ballast to 10 years only or something, which then, of course, lowers the ballast needs, but and looks better in the short run, but in the long run, you have a reduced safety against failure. And we don't do that. We do an accurate calculation. Therefore, our ballast is sometimes a little bit higher than with the competitors, but with the competitors, I would really urge you to look into the calculations and to look also how they do their calculations. One example is the design lifetime is only limited to 10 years. Another example is they use very high friction coefficients of up to 0.7, which is unrealistic in our point of view and which is unsafe to do. We are conservative there and use 0.5 as a standard in our calculations. So a lot of tricks are being played in that field. We are doing an honest calculation according to codes and standards, and want to rely on that. Regarding the solidity of the system, I already mentioned that we calculated the static reliability of all parts. We have done a design static calculations of all components by ourselves, and then we have given the whole order to a third-party institute in order to let them check that. And they came back to us that the system is completely safe and can be used in the in the wind and snow loads areas that we want it to be used. So a full static calculation has been done on the system, and also the rigidity of the system has been calculated so that we can see how rigid the system is, and the rigidity of the system has also influence on the ballast needs. The more rigid the system, flat roof system is, the lower the ballast need, and vice versa. I already mentioned shortly the new ballast sets, which ensure that the ballast is invisible below the modules, and it's very easy to install. It's a rail actually on which you can place the ballast blocks. It's completely flexible for different ballast blocks. We know that you guys in the UK use other ballasting options than that they are used in Germany or in France. So we have made an universal solution. So literally any ballast will fit. We have detailed it more in our installation manual so that you can see how to install it properly. I don't want to go into detail now, but it makes sure that the ballast stays where it belongs. We all know that the ballast has to be secured, has to be secure and stay on its place for 25 years design lifetime. We are quite proud about our bolt, which doesn't need a nut. It's a one-part piece, so it saves you hassle on the mounting side. It locks if you turn it by 90 degrees. It has a serration here on the back side. It's yeah, quite nice part. It looks quite simple, but yeah, it's taken quite a long time in order to engineer it. We have put here on the eave supports a stop so that you can slide in the module. It stays where it belongs due to the stop here, and then you can easily do your work. These graphic here shall enlighten you about the temperature equalization which we put into a system. So one of the enemies of flat roof system is wind load, of course. Another enemy is temperature, and especially temperature dilatation. So that means that the system is heated up during daytime at 70 degrees or 80 degrees. And in the winter, it cools down to minus 10 degrees. So you have a large temperature difference. And due to this temperature difference, the system shrinks and expands. And due to the shrinking and expanding over time, the system can crawl literally on the roof. And in order to prevent that, in order to manage that, we have put in here a dilatation space. So yeah, it's the same trick as they do in bridge building. If you put in gaps, etc., so temperature dilatation can be taken, and the system doesn't move on the roof. And this is very important so that the system stays where you have put it, so that it doesn't move around on the roof and makes damage to the foil, to other things on the roof, and makes a mess. So that's another important feature of the system. We have also engineered the system so that an uneven roof can be compensated. So there is a certain compensation in the angles that you can put the rails all together, which caters then for the unevenness of the roof, which is there. But then in case of wind action, the system becomes very stiff and can take the wind loads and transfer the wind loads. That's also a functionality of the system. I mentioned the pre-assembly, and which can save you up to more than 30% of time on site, and time is in this case also money. Yeah, this is about it. I want to show you short video on the mounting of the system so that you get an impression. So here you see, yeah, placing of the modules. This is a side deflector. The video is also available on our YouTube channel. Yeah, if you have time, go there and have a look. And now we would show you a short configuration of the system in our PV configurator. That would be done by my colleague Nils, who is doing R&D work in our company. And after that, we will go through our other product range so that you can get an impression about the general product range that we have.
Hi. Okay. I think it's my time to take over. Thanks for handing over to me. And as Marko already told you, we will have a brief look into our PV configurator and plan a flat roof system. Yeah, okay, perfect. So I don't know if all of you know our PV configurator, but if not, you can easily access it on pv-configurator.com, and it's free to register, and all our systems can be planned and statically calculated in this configurator. And yeah, it's relatively self-explaining. So if I would create a new project, I would just call it test Segen FS Pro. And I can just give it a project number if need be, or I can also create a fast calculation without statics. I will, in this case, create a calculation with statics because it's just a little more effort to do that, because I just have to enter the location and the terrain category. So in most cases, I would create a full-fledged configuration. I select the location, as I mentioned, by clicking somewhere on the map, and then the fields will automatically be filled here. Clicking on next will automatically determine the wind and snow load zones for this location according to the Eurocode with a national annex for Great Britain. Next thing I have to do is selecting the terrain category. In this case, this would be maybe a city. Also, according to the Eurocodes, the distance to coast and distance to edge of the city have to be selected, but this is also automatically done with Google Maps information. So in this step, you just have to select the terrain category. So really simple to use. And all the other variables I can select here are preset to standard values, like the service time, service life of PV system, and do not have to be changed. But if, for example, a structural engineer requires the system to be with 50 years service lifetime, you can select it here. But in most cases, just can just click on next. Also with the topography, we're in rarely cases at rock faces, peaks and hill crests. So in most cases, we're at just non-exposed terrain and can click on next as well. The next thing we would have to do is selecting a building type. For this presentation, we want to present the FS Pro. And for the FS Pro, we fix or we place the system on flat roofs. So I can select a rectangular flat roof or a freeform flat roof. And I would just select a standard flat roof. With flat roofs, one of the advantages of the configurator is that I can draw the flat roof from the Google Maps image. I have to select this separately. So instead of entering the data manually, I can do it interactive and then draw on map. I could also draw it on an image. So if I would have a drawing of the system, so PV Planner sends me a system with the layout also already on the PDF plan, I would just import that. But in this case, I will just draw on the map and see if I can find something here. So maybe I will just select this building here. It looks like a flat roof, and I can just draw that by selecting this draw rectangle top right, and then I just draw it with 3 clicks. The roof appears. Next thing I have to do is selecting the reference line. So where the system is aligned at for facing not directly south. So if I wouldn't select anything, the modules would be facing exactly south. But in most cases, I would align them with a edge of the roof to improve the capacity of the roof and quantity of modules. The sizes of the roof are also taken from Google information, so I don't have to enter any dimensions here, apart from in the next step the roof pitch, which could be 3 degrees, for example. The building height, that would be maybe 8 meters. Parapet height could be 300 mil, and parapet width maybe 200 mil. And then I get to the next step with roof coverage. I just saw in the question and answers, maybe I'm taking this directly into the presentation, the question for a rubber roof, I think I saw it. So we have the option of bitumen, foil, gravel, and custom roof. So for us, for the calculations, just the friction coefficient is important. This can be measured on site, or if I select one of these roof types, a predefined friction coefficient is selected. So in case of a rubber roof, I would select a foil roof, like a membrane roof. And a lower friction coefficient would be selected then with a bitumen roof, where the system is less likely to shift because of the rough surface of the bitumen. Or anything else you wanted to add, Marko?
The protection pad is the other, the roof protection pad is the other influential factor. So there should be also be chemical compatibility between the roof and the protection pad. So our protection pad is made out of polyethylene, and this is a material which is widely compatible with all the roof coverings, and which also the roof manufacturers use as protection pads for other products. So chemical compatibility is one point, and then we have UV stability of the protection pad, and then we have also the fire protection of the protection pad. These three factors. Yeah.
Good. Next step would be selecting a module manufacturer. We have a database with the most common or almost any module manufacturer. So maybe we have a JA Solar module. I would just select sort by manufacturer, and then select a module. Yeah, let's not dig too deep into it. You would just enter the module type. And yeah, I would just select this JM 4454, and all the important parameters for us are on this database. So length, width, height, and weight are very important for us. Also the wattage of the module, which can be changed here after creating the project, to not have to completely redo the project. If the wattage changes, I can just change it here, so my configuration stays valid. Okay, and then I just click next, and the configurator will now show me only the systems compatible with the selected roof type and roof connection type. So in this case, I would select a ballasted roof or a ballasted system. And a configurator gives me the console. I will get to this later. The FS Pro. So the current and new version of our flat roof systems, and still the old FS 10S, FS 18S, and FS 10 East West, which will be cancelled in the future. But in this case, I would select a FS Pro 10 East West. So as Marko already said, most of our customers preferring east-west systems with 10 degrees pitch because of the better roof area usage. And yeah, so in this case selected. I can select the module orientation, the module clamping side, so I can also clamp on the long side of the module. where I have to say short side clamping is the most economic way to clamp on flat roof systems, because we need less rails, of course. With a long side clamping, we would need 2 rails in the middle, and the next module would be needing 2 rails again. So if short side clamping is possible, select short side clamping. I could select the row distance. It will show me only rail lengths that are compatible with the module size. So in this case, we would have 3 options. 2360 being the shortest, with almost no walkway. And if I would like to have a walkway in the middle, so in the top section of the modules, I would select the 2440 mil. And if I would if I would require an even wider walkway, like maybe 40, 50, 400, 500 mil, I would select the largest. But in this case, I would select the middle, which improves as well the ease of installation. So I can walk in between the modules, connect the module electrical connectors, and yeah, and then place the modules without yeah, crawling over the module. I can select also a third rail, as Marko already mentioned. I don't have to select it. Automatic will switch them on if needed. So to my knowledge, in the UK, snow loads aren't that high that the system will require it. So yeah, but if it is as high, the third rail will be selected automatically. These are standard values. The ballast block mass, that's just what's shown in the report. I could change that to maybe 20 kilos for a N7 concrete block, for example. The friction coefficient, that's what I mentioned earlier, is taken from the roof coverage. So with the foil roof, we give 1.5 as the friction coefficient. The higher the friction coefficient is, so the worse the system is able to shift on the roof, the lower the ballast needs to be, because yeah, ballast is against shifting as well. And yeah, but I would keep this as standard. Partial safety factor for dead load is explained under the selection tab, so I'm not going too deep into that because I will just keep this as standard as well. And then I click on next. I can select our various module clamps, standard ends and mids, and the RS1 ultimate clamp, which I will explain after this presentation. But I will just keep it as standard mids and ends. I can select the color, silver and black. I'll keep this as black. So as soon as the module selected in the module database is black, the clamp color will be also set to black, but I can change it if I needed to. The next step, I will get to the configuration screen where I can already see the roof, with a full layout. So the configurator will automatically just completely cover the roof with modules. And with flat roof system, it's quite simple to just, as I can see through the modules, I can just select modules by dragging the mouse and delete them. So where there are obstructions, like in this case, it looks like there's an obstruction, I can just delete them. I could also select all modules, and with the arrow keys, shift them to where I want them to be. So maybe in the middle of the roof. And then maybe we have some more obstructions in the middle. I can just select them by clicking them, and deleting them by clicking delete on the keyboard, or on the top with this little bin here. Okay, and then next step would be bill of material and static calculation. And if I click that, the configurator will calculate the ballast required for each module. showing that in different colors for the different categories, and also with the numbers indicating the ballast in kilograms. And yeah, this is basically it. In this case, we can see that some modules are a lot higher. This is due to the fact that they are, as we can see, not connected to the field. So as the configurator does not know the perfect layout for this roof, in this case, I would, as the planner, I would select these modules, attach them to the array underneath, because it's just 2 double modules, and then calculate it new. And due to the larger overall module quantity in interconnected, the ballast is reduced quite drastically, because all of the modules, the surrounding modules, help with lifting the module off and shifting the module as well. And so this makes optimization of arrays quite simple.
Yeah, one of the questions that came up is what is the minimum ballast need? And as you can, there are 2 questions. What is the minimum dimensions of the ballast that has to be used? And here we see how low the ballast need can be. As you see there, we have modules which have to be ballasted only with 5 kilograms. This depends, as Nils explained, of course, on the location, on the wind load of the project, building height, etc., and the geometry of the array. The more modules you are able to connect, the lower the ballast need. Regarding the minimum dimension of the ballast,
I have a good information on that, actually, because I saw this question as well. And in the background, I opened a PowerPoint presentation a colleague that did for different ballast block sizes. So as Marko already mentioned, we're using different ballast blocks, or our customers are using different ballast blocks in every country. For example, in the UK, N7 concrete blocks are used quite often, even if they are not used like here, just put on the rails, because it's quite insecure. In most cases in the UK, they're used in ballast trays or on our ballast rails. But for these small required ballasts, we found that even these small, I'm not sure how they're called, like pavers could be laid even into the rail. So if they have a width of 60 mil, they could be even laid into the rail, which would be, in this case, which I just did show, with 5 kilograms, could be a nice option to also prevent them from falling off the rail, and not over ballasting with too large stones. And yeah, so this is.
But perhaps the recommended ballasting option for the UK would be N7 blocks, right?
Yeah, I often heard that these are very very common and often used. Yeah. But also larger pavement slabs. So German customers often use like 30 by 30 pavement slabs. Also quite good to use. And
so it's quite flexible.
And also with the ballast rails, which you can align on the rail individually, you can adjust for the width of the ballast stones or ballast blocks that are used. Okay, and last step is the part list. You would get the part list with, of course, our list prices, so no discounts on that. But you would, with this part list, of course, go to Segen and get a quote there. And yeah, so you can export the roof, the project report, which would be important as well for Segen to give you a quote. And you can have that in extended version, including statics, or in the short version without statics. And I will just download this one. Sometimes if the roof is a bit bigger, it takes a bit longer. But in this case, it's not too big. And the report contains everything that's that's needed to for customers to see what has been planned, and it's a nice document to hand out to customers. One information as well that's maybe important or interesting for some of you. This Renusol logo on top left can be changed in the configurator to any company logo in the configurator by just selecting settings here, and then you can under user data or customization, you can import an own logo, and then you have your own report to be handed out to customers. Quite a good option to yeah, makes a good impression, I think, and you have a professional report with all the information statics in there, and all the calculation that can be checked with by a structural engineer.
And also, I want to point out exactly that table, what you have shown, Nils, is a main difference to our to any of our competitors, actually, because we give here clearly the information, the CP values for each and every module, and we give also the formula with which the ballast is being calculated. So a civil engineer or anybody who wants to calculate can check our calculation for wind loads. And this is not the case with most of our competitors, because their calculation is not visible, it's not checkable, and it's not, yeah, nobody can see how it's being calculated. And we are completely transparent there. Yeah.
And as I noticed with some customers in the UK, more and more structural engineers or surveillance institutions are asking for correct documentation and calculation, and that's where our reports come in handy, and it's really simple for them to check. And
okay, thank you, Nils. I would propose that we go through the questions, because most of them relate to the flat roof system, and after that we go in the presentation of our portfolio regarding on-roof systems. Okay, one of the question was for a south-facing system, which needs the wind deflector, would the material cost be slightly higher than with the east-west variant? Definitely. East-west system is always the most economical system. A south-facing system is always more expensive. Even if no wind deflector is used, it's more expensive than an east-west system. So south-facing system, per definition, is more expensive than an east-west system. Next question, what is the minimum dimension for the ballast? We answered that. Then question, Marko, due to the climate crisis, we can expect to see more extreme weather conditions in future. So out of interest, we already seen this in the UK, higher wind speeds. To what extent in wind tunneling tests do you factor in wind speeds potentially becoming higher in the coming decades? Okay, a very good question. So in the wind tunnel test, we do the wind tunnel test so that it's variable for different wind speeds. We can input any wind speed in our calculation and then calculate the ballast for it. Which wind speeds are we considering? We are considering the wind speeds by codes and standards in the respective country. In the UK, it's the British standard for wind and snow loads, and from that we take the wind speed. And we know that in Europe, the codes and standards organizations are working on these standards in order to make the wind speeds higher, but they are doing that by measurements. So they are doing measurements for 5 years, for the last 5 years, for example, and then they see if there are higher wind speeds, etc. Then they put the wind speeds up, and these wind speeds have to be used. So we have no choice, but we have to use the wind speeds defined by the British standards, and we use that. So our configuration tool uses these wind speeds automatically. But if you have now project where you want to build in higher safety, so to say, you have another option. You can choose another design lifetime. You have seen that our standard design lifetime is 25 years for mounting systems. And if you take their 50 years, you will get higher wind speeds. And therefore even more safety. So, why is it? Because it's only statistics. In 50 years, the likelihood of a very big storm is higher than in 25 years, therefore the wind speed is higher. So to make it, to answer it short, we are using wind speed from Code and Standards, here British standard. The guys who write the standard are responsible for the wind speeds. They are working on it, and yeah, if you use 50 years design lifetime, you can have you get more ballast, more safety, and yeah, that's it. Another question, very important, can this be used with southeast, northwest orientation? So the question is, can we combine the system? Answer, yes. We can combine the south-facing system with the east-west system. So if you have an east-west configuration, you can build a south-facing row or a single row at the end. This is possible. Is it in the configurator? No, it is not yet. So the colleagues are working, but actually physically it can be done, and it has been designed that it can be done. So that was one of our wishes that we wanted to achieve. So east-west system with south-facing system can be combined.
So if there are these special projects that come up, please always feel free to reach out to us, and we will find a way to make that possible. So we can calculate it manually, but in the configurator for customers not yet available. But yeah, so we'll do our best to help you there.
Yeah. One other important question. I mentioned the attachment of this flat roof system to a trapezoidal sheet. And now Josh is asking, the optional self-drilling screws are not available at our distributors. Can you explain what they are used for and if suitable alternatives can be used? Nils, for you.
So I'm just curious why that isn't available. I'm not sure if it is the screw that is shown here. So this, I guess this is the screw Josh is talking about.
Yes.
And this indeed is a error in the configurator that I noticed last week. And the self-drilling screws that are needed to fix the system to the roof are the Metasol screws. I'm not sure if you're familiar with that, but that's the I think 900-301 or 400-301. Yeah, that's this screw is the right screw, the correct screw that will be replaced with the one in here. So that's still incorrect, but this one should be available at your distributor.
But it is a standard screw from our Metasol range, so from our short rail system, which can be attached to the metal roof, and it's a standard screw, and it should be available at every wholesaler. So
correct.
it is there. And you asked about the function. So the function is you have the rail of the flat roof system, you have the metal roof, and you connect actually the rail of the flat roof system to the trapezoidal sheet. That's the function.
Correct. And if I would select a fixed system, so if I would select a trapezoidal roof and plan a fixed system, of course, the configurator would plan with the correct screws, so with these 400-301. But the recommended parts are just really accessories, and this screw made its way into it. I'm not sure why, but yeah, we will replace that.
Okay, good. Next question. What was the degree threshold for a flat roof? It's 5 degrees, so 5. 5 is the threshold at Renusol. Other guys only do 3. For us, it's 5. Up until 5 degrees, you're good to go. with a ballasted system. Above 5 degrees, you should fix it to the roof. What is your advice on best method for calculating friction coefficient on site? We have a document on that, and there you can see our advice and you can follow the procedure. It's in our download area on the website. And there you see general data Renusol, and then you see record static friction coefficient. If you follow that document, you're good to go.
Usually you're good to go with the values we provide as well, but we have to state that it should be measured, or it has to be measured to get correct values. So our values that we set as standard are on the safe side, but better to be measured. I had another interesting question. Good morning, Marko. Would fitting the FS Pro system using Renusol fixings invalidate the roof manufacturer's guarantee? In this case, so if we fix systems to the roof, this is in most cases in the UK done with Nicholson roof track fixings, with whom we are in very close contact and discuss projects in the UK quite often. And Nicholson is giving warranties for their products with the correct membranes, for example. So if you have a Zika membrane, reach out for Nicholson, and they can, in combination with us, plan the right system with the right fixation, still maintaining warranties for the roof. So I think that's...
Here is a question which is quite important. With the system, am I correct in saying no lightning protection is needed if you add the lightning protection clips onto the array? That is not correct. What we have said is that the system can carry actually lightning capacity. So it is connected by the clips so that lightning current can go through the system. And potential equalization can be done also through the system. That is what the system can do. But the system does not replace lightning protection on the roof. It's not a replacement for that. But if you have a lightning protection on the roof and you are putting a flat roof system, then to my knowledge, at least you have to prove that your flat roof system is capable of transfer the grounding currents, and this can be done by our system, and for that the system is fit. So does the system replace the lightning protection on the roof? No, it doesn't, but it is fit to be used in combination with the lightning protection. That is our...
Also be always to be checked with an electrical engineer familiar with lightning protection, because there are so many standards in different countries. We just made the system capable of being able to be integrated into a lightning protection system, but yeah, this has to be checked with the...
Yeah. Is there a cable management tray or clips?
Let me see if I can component data sheet. So on our website, we have a data sheet section with all our data sheets. Let me just see if I can So there are options for the FS Pro rails, for example. There is a small cable tray that you can click on the side. Let me see if I can find it in here. So there is a little aluminium. I think you saw it in the video before, but there's an aluminium channel that you can click on the rails from the outside to cater for a smaller amount of cable. But yeah, unfortunately, there it is.
There it is.
So that's the cable tray for small amounts of cable, but for a larger amount of cable, you would have to use a large cable tray. So if you would have, I don't know, 30 DC cables, you would have to source that separately. Also, of course, what I prefer to use with system installations is these cable straps with a clip to click it onto the system. Wire clips. So, for example, this one is for one cable. This one, like with a cable strap, you can just click that onto the base rail or onto the supports or on the ballast rails. Also, there is this Omega clip. You can clip this into the ballast rail, so to run cable, also a smaller amount of cable, maybe 4 or 6 cables, in line with the array, also possible. So there are different options to do that.
Yeah. Another question regarding the alignment of the array on the roof. What is the minimum distance to the roof edge? It's 0.6 meters.
Correct.
60 centimeters is the minimum distance that we need. Yeah. Can you show the advanced options for alignment, positioning options? There you can see this is the minimum distance, is 600. Below 600, you can't do anything. But if you want to have a setback, so if you want to define like 2 meters from the edge, you can put it in there. So no modules are then put in this area. This is the possibility to do a setback. This was one of the questions as well.
Yeah. Little tip as well, this setback can be used to reduce the ballast in some cases, because as the edge distance defines the wind tunnel testing results quite largely. So in some cases, it's worthwhile looking at shifting the modules more in the center of the roof. Not in every, but in some cases.
Putting a system on green roofs, is that an option? It is actually, but for that you have to have a higher distance to the green roof. We are working on one option which will cover that. Until that, yeah, actually it can be put on the green roof, but we are working on a version which can have a higher distance to the green roof. Would a larger walkway between east-west modules orientation ever require wind deflector? Answer is no, it wouldn't. For portrait orientation is 10 degrees the only option? Yes, it is. Portrait orientation 10 degrees is the only option, because 18 degrees would require, of course, very big, very high supports, and this is unrealistic. So 10 degrees for a portrait is fine. Very important question. Who do we send a design request for assistance with the system design? And here we have my colleague, Chris Dunning. Chris, he is responsible for technical designs in the UK, and it would be him. You would send directly the designs, or to Darren, Darren Painter. Many of you will know him. So these two colleagues would be available, or you send it to our email address, ts@renusol.com, and then Chris and Darren will get the request and come back to you with the design.
Yeah. Yeah, sending it to the shared inbox, TS UK, will reach most colleagues working on it. So, and that would provide the quickest answer.
I would like to thank you, thank all of you for your patience, for your time. I hope we gave some valuable information to you. And thanks a lot to Segen, of course, for distributing our systems and yeah, for organizing that event. Appreciate it very much. Thank you.
Yeah, thank you very much. Thank you, Nils and Marko, for hosting that.
Cool.
Perfect. Thank you very much.